So in this case, I'm going to use that 6.7 I had, which was the delivery times of the pizza. The variance of my delivery times of the pizza was 6.7, and that is going to be 2.6. So 2.6 is going to be my standard deviation of the delivery time of my pizza to my house. Okay, so it's once you can calculate the actual standard deviation using this formula like we did before. Now, let's look at the next one, which is basically the standard deviation. Standard deviation, if you can look at it, is actually the most important measure. Remember, I said variance also, but it is both of them are very same. One is the square root of the other. That's the reason I said both of them are very, very important. But anyway, the standard deviation is really important in the sense that you can find how things are varied in this world. So if I'm going to make Coca-Cola cans, okay, Coca-Cola cans, the diameter of the Coca-Cola cans, if I take the measurement of that, one Coca-Cola can be maybe just a little tad difference than the other, 0.0001 inches more than the other or less than the other. So it's actually, this is basically because of the process. When people make Coca-Cola cans, they want to make it to the right diameter, but then it can be plus or minus of the diameter as they make because of various problems of the processes and things like that. So it is very important for the manufacturer of the Coca-Cola cans to look at the statistics and see how to do this in the right way. Okay, so the idea is that usually you have the statistics usually can be said this way, that that if I'm going to have the making of the Coca-Cola cans in a very normal distribution, most of the things that we do in this world is normal distribution, basically. And if I can say that, if this is the mean of the population, okay, and or the mean of the sample, whichever way you want to look at, this portion is 1 sigma, which is 1 standard deviation. Okay? This portion is 2 sigma. And this portion can be 3 sigma. What it basically means is that this area here is about 1 standard deviation away. 1 standard deviation away from the mean, around the mean. And this portion is 2 standard deviations away from the mean, and so on and so forth. So what people have done is come out with some empirical rules. The empirical rules are this. Empirical rules are basically 1 standard deviation in either direction of the mean accounts for 68% of the data. 2 standard deviations account for 95% of the data. 3 standard deviations account for 99% of the data. Let's see what we mean by this. Okay. So let's talk about 1 standard deviation. Let's say that the average exam score for my statistics class is 88 points. Let's say that the standard deviation is 4 points. This is what I calculated over a period of time. This is 4 points, is my standard deviation. And usually, most of my students get these points in a normal way. This is my normal curve. It's called the bell-shaped distribution. The bell-shaped distribution, this is a normal curve. This is how students actually get the points. Okay? 1 standard deviation above the mean, which is this mean here, okay, above the mean would be 92 because it is 88 plus 4. And one standard deviation below the mean is 88 minus 4, which is 84. Okay? So I have one standard deviation above the mean and one standard deviation below the mean. The empirical rule tells me that for this one standard deviation, 68% of the exam scores will fall between 84 and 92. 84 and 92. What does that mean here? So if my average is 88, okay, so this is 92 and this is 84. 68% of my class will fall in this. This is a true bell-shaped distribution or normal distribution. So the empirical rule states that 68% of the people, 68% of the scores will fall between 84 and 92 if the average score was 88. If the average score changes, the standard deviation is to those also changes, and so the bell shape will be a little different. Okay, so let's look at one more thing. What is my 2 sigmas? That means what I'm saying is if there are 2 standard deviations, again, I'm going to look at my average, my mean is 88, and I'm going to have a bell-shaped equation. If I have 2 standard sigmas or 2 sigmas, what is my, it is going to, my rule, empirical rule is going to tell me that 95% of the data will fall between the 2 standard deviations. What is my 2 standard deviation? The 2 standard deviation is going to be 88 plus 2 times 4, which is going to be 96, or 88 minus 2 times 4, which is going to be 80. So in my class, if I say it's going to be 2 standard deviations, it is going to fall between 80 and 92. And this is my 2 standard deviation. So basically I can say that the empirical rule states that approximately 95% of the data values will fall within 2 standard deviations from the mean. In our example, 2 standard deviations equal 80 and 92. So 95% of the exam scores will be between 80 and 92. Okay, and we can do the same thing for 3 standard sigmas. So let's do that. For the 3 standard sigmas, I can say that 3 sigma, which is 88 plus 3 sigma, 3.4, which is going to be 100, and then 88 minus 3 sigma, which is going to be 76, 3 times 4. So this is going to be 76, and this is going to be 100. So this area basically is my 3 sigma. So I can say that 99.7% 99.7% of the data values will fall within 3 standard deviations. So I would expect all my students to be between, almost all my students will be between 76 points and 100 points. Okay. So basically we can say that according to the empirical rules, whether it is 1 standard deviation or 2 standard deviation or 3 standard deviation, there is a percentage that I can go with. One standard deviation is going to be 68% of the data. 2 standard deviation is going to be 95%. 3 standard deviation is going to be 99%. So we can pretty much look at mu. If I want to look at it, I can say the actual way to find this would be mu plus k sigma is the answer. K is the standard deviations around the mean, and this is my standard deviation and this is my mean. And that gives you the idea of how standard deviations work. Okay, so let's go to module 5 after this.